In September 2017, 5 great white shark carcasses washed up on the beaches near Gansbaai, South Africa, one of the most productive white shark hunting grounds on Earth. Each body had been opened with what researchers described as surgical precision. The livers were gone, not damaged, not partially consumed, gone, extracted so cleanly that the first biologists on scene initially suspected human involvement. It was not humans. It was 2 orcas, a male and a female, who had been working that coastline for months. The event forced marine biologists to confront something the data had been quietly suggesting for years. The most feared predator in the ocean has a predator of its own, and the consequences of that relationship extend far beyond 2 animals fighting in the water. To understand how thoroughly orcas dominate great white sharks, you need to understand what a great white shark actually is. An adult female great white can reach 20 feet and weigh more than 4,500 pounds. Their bite force approaches 4,000 pounds per square inch. They have been the apex predator of coastal marine ecosystems across every major ocean for roughly 16 million years. Elephant seals, sea lions, dolphins, other sharks, nothing in the water treats a great white as prey. Nothing, that is, except orcas. Adult male orcas can reach 32 feet and weigh 22,000 pounds. They travel at nearly 34 miles per hour in short bursts and can cover 99 miles in a single day. They hunt in coordinated groups, communicate through distinct pod-specific vocalizations, and pass learned behaviors down through generations in ways that researchers now describe as cultural transmission. The physical mismatch between an orca and a great white is enormous. What makes the relationship between these 2 animals remarkable is not simply that orcas can kill great whites. It is the scale of the behavioral response that killing produces. In 2019, researchers from the Monterey Bay Aquarium published a study in the journal Nature Communications documenting what happened at southeast Farallon Island, a critical white shark hunting ground off the coast of California, after orcas entered the area. The sharks left. Not gradually, not partially. Every instrumented white shark in the study area vacated within hours of orca presence. In a normal season, researchers document roughly 40 elephant seal predation events by white sharks at that island. In the years following documented orca visits, that number dropped to 0. Not one shark remained to hunt. The prey population was left entirely untouched, not because the sharks were full, but because they were afraid. The scale of that avoidance is what set off years of follow-up research. Scientists expected the sharks to return within days or weeks once the orcas moved on. They did not. Instrumented white sharks tracked after orca encounters stayed away from their preferred hunting sites for periods averaging close to a year. A single orca passing through an area used seasonally by dozens of white sharks was enough to empty that area for an entire hunting season. Salvador Jorgensen, the Monterey Bay Aquarium researcher who led the study, described it as a landscape of fear operating at an oceanic scale. The orcas did not need to be present. The memory of their presence was enough to restructure how an entire predator population used the ocean. The ecological consequences of that restructuring became visible in South Africa faster than almost anyone expected. Great whites have historically concentrated off the Western Cape, particularly around Gansbaai, where Cape fur seal colonies provide a reliable year-round food source. After the documented orca attacks beginning in 2017, white shark sightings in the region collapsed. Shark cage diving operators who had run consistent trips for decades began reporting entire seasons without confirmed encounters. By the early 2020s, researchers confirmed that white sharks had made themselves extremely scarce across the coastline they had dominated for generations. What filled the vacuum was a species called the bronze whaler shark, a mid-sized requiem shark that occupies the next tier down in the food web. This is where the story stops being about 2 predators and starts being about the entire system beneath them. Bronze whaler sharks, also known as copper sharks, are normally kept in check, partly by the presence of great whites. With white sharks gone from the Western Cape, bronze whalers expanded. They began appearing in numbers along beaches where white sharks had previously dominated. The orcas, operating without the boundary that white shark presence had historically imposed, began attacking bronze whalers as well. Meanwhile, Cape fur seal populations, no longer under consistent predation pressure from white sharks, began expanding their own feeding range. Cape fur seals eat African penguins. African penguins are critically endangered. The removal of a single apex predator, driven entirely by fear of another predator, was cascading down through 4 separate species in ways researchers are still working to map. The mechanics of how orcas actually kill great white sharks are precise in a way that tells you something important about the intelligence behind them. Orcas target the liver. In white sharks, the liver is enormous, making up roughly 1/3 of total body weight, and it is extraordinarily energy-dense, packed with squalene and lipids that represent one of the highest calorie food sources in the ocean. To reach it, orcas have developed a technique that neutralizes the shark's primary defense, They flip it upside down. Inverting a shark triggers a neurological response called tonic immobility, a reflex that leaves the animal motionless and unable to fight back. A 4,000-pound predator with one of the most powerful bites in marine history becomes, within seconds of being inverted, completely paralyzed. The orcas then open the shark near the pectoral fins, compress the body, and extract the liver while the shark is still alive and immobile. Researchers who have observed the behavior in multiple locations describe the extraction as functionally surgical. The rest of the carcass is largely left intact. In South Africa, the first time observers watched this happen in real time was June 18, 2023, when a male orca named Starboard pursued a white shark to the surface, grabbed its left pectoral fin, and eviscerated it in approximately 2 minutes. Starboard then surfaced near a nearby shark diving vessel carrying a piece of liver in his mouth. That event was the first documented case of a single orca killing a great white shark alone. Every previous documented kill had involved cooperative group behavior. The cooperative version of this hunting strategy was documented in unprecedented detail in the Gulf of California beginning in August 2020. A group of orcas known as the Moctezuma Pod, named after the best-known individual among them, was filmed from the surface and from drones carrying out coordinated attacks on juvenile great white sharks in a manner that researchers described as unlike anything previously recorded. In the first documented incident, 5 female orcas pursued a juvenile white shark, pushed it to the surface, flipped it, and extracted its liver. Within minutes of completing that kill, the same group attacked a second juvenile shark and repeated the process. Researchers confirmed 3 separate takedowns across 2 hunts by the same pod. The livers were shared among the group after each kill. What made the Moctezuma pod's behavior particularly significant to researchers was the age of the prey. These were not adult great whites, which tend to flee immediately upon detecting orca presence. These were juveniles, likely animals that had not yet learned to associate orcas with danger. Jorgensen and other researchers raised a question that remains unanswered: whether white shark anti-predator flight responses are instinctual, or whether they are learned behaviors transmitted through experience, the same way orca hunting strategies are transmitted. If the flight response must be learned, juvenile sharks born into an ocean increasingly populated by hunting orcas may be encountering that lesson for the first time in the worst possible circumstances. The Moctezuma pod returned to the same area in August 2022. 5 orcas, including 1 adult male, 1 adult female, 2 subadults and 1 calf, carried out the same attack pattern on another juvenile great white. The presence of a calf in the hunting group was notable. Calves that accompany adults during coordinated hunts are understood to be observing and internalizing the technique, adding it to a behavioral repertoire they will carry for decades. Andrew Treitz, a biologist at the University of British Columbia, described the Moctezuma pod's approach as a unique feeding strategy that is probably not shared by any other group of orcas in the world. The geographic specificity of the behavior, orcas in a particular location developing a specialized approach to a particular prey species, is itself evidence of cultural transmission operating at the level of a distinct population. The cross-ocean consistency of the hunting pattern has since become one of the more striking data points in the research. In October 2023, off Portland, Victoria, in southern Australia, a pod that included 2 named individuals, Bent Tip and Ripple, was observed hunting in the same area where a juvenile great white carcass was later recovered. The wound pattern on the carcass matched the attacks documented in South Africa and Mexico. The orcas had targeted the same anatomical zone, the region near the pectoral fins, with the same apparent precision. Researchers confirmed the attack was consistent with documented kills across 3 separate oceans: South Africa, Mexico, Australia. Different pods, different hemispheres, same technique. The question of whether these behaviors represent convergent development, separate populations independently arriving at the same solution, or some form of broader social learning transmitted across ocean populations remains unresolved. What is clear is that the hunting method is not random opportunism. It is a refined, repeatable strategy that minimizes risk to the orca while maximizing caloric return. The liver of a single adult white shark, representing roughly a third of the animal's body mass at exceptional energy density, likely delivers more usable calories per unit of hunting effort than almost any other marine prey item. Orcas are calculating this return, consciously or not, every time they target a great white over other available food. The behavioral ecology research around all of this has introduced a concept that researchers are now applying to marine systems in ways previously reserved for terrestrial ecology. The landscape of fear, a framework developed largely from wolf and elk studies in Yellowstone, describes how the mere possibility of predator presence alters prey behavior even when no predator is actively hunting. In Yellowstone, elk stopped grazing in certain areas, not because wolves were there, but because wolves had been there. The same principle is now documented operating in the ocean, at a scale that dwarfs anything seen in terrestrial predator-prey systems. White sharks are vacating hundreds of miles of coastline for year-long stretches, based on encounters that may have lasted hours. The human role in producing the conditions for these encounters is something researchers are careful to note. White sharks and orcas both spent most of the 20th century being killed in large numbers across their ranges. Shark finning, direct culling programs, bycatch, hunting for sport and for perceived threat reduction, all of it depleted both populations to levels where natural behavioral dynamics between them were effectively suspended. The assumption among researchers studying these interactions now is that orca predation on white sharks is not a new phenomenon. It is an old one, resuming as both populations partially recover from a century of removal. South Africa's white shark population, by most current estimates, sits somewhere between 500 and 1,000 individuals. It is not a recovered population, it is a depleted one. The orca attacks accelerating that depletion through behavioral exclusion from preferred habitat are occurring in a system still carrying the weight of historical collapse. Whether white sharks can behaviorally adapt to sustained orca pressure across their range, whether juvenile sharks can learn anti-predator responses faster than orcas can learn to target them, whether bronze whalers can absorb the trophic role white sharks are vacating in the Western Cape. These are open questions that researchers are tracking across multiple ongoing studies. The Farallon Island white shark population has shown some signs of return in recent years, though numbers remain below historical baselines. In the Gulf of California, researchers are attempting to determine whether the Moctezuma pod's access to a shark nursery area is seasonal or persistent, and whether juvenile white shark populations in that region are experiencing measurable decline as a result of repeated targeted predation. The research coming out of all three ocean basins is converging on a conclusion that marine biologists would have considered implausible 30 years ago. Orcas have not merely learned to kill great white sharks, they have learned to functionally reorganize ecosystems by doing so, exploiting the fear response of a species that dominated marine food webs for millions of years and turning it into a tool for reshaping everything below it.